So we have in this case, we plus a CNOT, which is Q0, Q1, and then followed by the Hadamard gate on Q0. Okay, so let's see. Okay, so we first apply CNOT on Q0, or the initial state. Initial state is cat 0, 0. We have two qubits, they're all in 0. And so when we've applied the CNOT on this initial state, nothing should happen because the first bit is 0, second bit is still 0, so it should be exactly just 0, 0. Nothing changed. So first step, second step, and then we do the Hadamard gate. So now we basically do the Hadamard gate. Oh, this is easier now. We still need to add the I gate. We still need to add that I gate, blue. Yeah, still need to add that blue I gate there. So this start Hadamard gate, tensor product identity gate on the cat 0, 0. And the identity gate on the 0 is 0. Hadamard gate on the first bit, we basically we did this many times by now. Basically, the superposition. And then the tensor product, the identity of 0, cat 0 is 0. So, and there, by definition, we already get this. So this is already a product of that. So let's see. Yeah, so in IBM, it's called 0, 1. In our case, it's 1, 0. Yeah. So it's a bit different, but this definition, oops, sorry, that is actually already a tensor product, right? This is a tensor product. So there, so it's not entangled because we actually use a tensor product or even calculate that one. So that's the final state. Final state is a tensor product. So not entangled. Yeah. So there. So I think in previous lecture I was confused by that little ending and bigger ending in my writing and IBM display. So yeah. So good. I guess I can. Next time if I give this lecture again, it will be more clear. Sorry. Yeah. I guess when you are doing that homework assignment, you should also mention this. Just make sure when you are trying to explain the Q sphere and IBM's the probability distribution, make sure that as long as you mention it's the ending is opposite, that's fine. So yeah. Okay. So for the next week, we actually, I think we are now ready to really do some quantum algorithm stuff now. But I guess we can, it's kind of going slow in a way. We are going to still just using the IBM tutorial on the introduction, query mode, and then talk about this. How do I pronounce this? Is it German? Is that German? Danny, Joshua, Justin, and you know how to pronounce this?
Probably Deutsch.
It's Deutsch.
Deutsch. Okay. Thank you. Okay. All right.
Apologize. Can you? Yeah, that's Deutsch.
Okay. Deutsch. I tried my best. Okay. So you can actually read this on your own. It's really a lot. We can skip that. That's just digital logic. Unitary gate, Deutsch's algorithm. It's really it doesn't do anything. It's just a toy model, like Lego, kids playing Lego or something. It's really very, very simple model. But you can look at it, see how it why the quantum people trying to say this is to show the advantage of the quantum computing. It's not a good example, but even the tutorial say you had to start somewhere. So yeah, I actually put this one on the IBM Quantum Lab. Hold on, where is that? Oh yeah, I put it in my IBM Quantum Lab. Basically modify the tutorial code I put in the Deutsch algorithm. Yeah. But this actually this is the simplest algorithm. It doesn't run in Google Colab, only run in IBM Quantum Lab, unfortunately. So, well, unfortunately, depends on what you mean. There are also a few other examples, like the IBM's tutorial, like try to search for the number, is actually, but that one actually directly use the grooves algorithm, which is kind of seem to be a bit not from the beginning. I thought Deutsch's algorithm probably is simpler than the grooves algorithm. That seems to be way too much as a tutorial to start with. So I decided to still go over with the Deutsch's algorithm first. So that's what I have. So you can look at it and prepare for the next week. But it's extreme. It's very simple, but I guess the idea is quantum computer. For me, the basic idea is it's just different way of thinking. It's so it really doesn't solve any practical problem. It's really a toy model, but it's just there to show the way of thinking, or proof of principle in a way. So. Okay. had some of you start to think about how to do that assignment? Let me look at the assignment. Now I go back to think about it. It's really a challenging problem. Yeah, HH. What's that? Yeah. It'll be fun. Yeah. So remove one H will be a quantum entanglement. Add another H. Yeah, actually not don't have a quite intuitive explanation at what happened then. With just one H is the entanglement. With two H, it becomes even probability. Hannah D, Joshua, Justin, have you got time to look into this?
Well, I felt like I need to go back, and that's like I looked at the book to have a better explanation, honestly, to figure out when to use sequential, when to use parallel. But yeah, I felt like would be solved with just following some matrix multiplication. I don't know, but I'm not sure.
I see. Joshua say he coming. We did go over the first part. The first part we went to today. We did went through them today. Yeah. So
I think that would help a lot.
Oh, hopefully, yeah. So, but this one added the CNOT after that. So
yeah.
Yeah. Okay. Any other questions? That's what I prepared today. Actually, even today, even though I went fast, is the 3 examples and then the overview of the next class. So we actually already in the middle term part, you really need to think about which paper you want to pick. I already gave the assignment. Yeah. So, and then it doesn't have to be the paper I list here. There's a lot of interesting idea. Is some of you actually think about even doing a thesis on this, so you might pick something even related to that. So so next class, I put the Deutsch algorithm notebook on Colab. It just doesn't run. Those are the previous results. It doesn't even run the first part. So, but in the IBM lab it runs. So. I thought I had that. I guess I left that part. Yeah. Sorry.
Is it one of the courses that we need to look at, or we just look at the query algorithm, quantum algorithm, or something?
Let me put that into the chat. Maybe I put the notes already there. So good point. So I'm going to add. How do I spell Deutsch? So,
D-E-U. Oh.
EU.
Yeah. TSCH, I think.
TSCH. Algorithm.
Close enough.
Deutsch algorithm.
It's a German word, isn't it?
Yes.
Yeah, it probably is a German word. Yeah.
It means Germany, right? Or not?
It does.
Yeah, they call their own country Deutschland.
Oh, is it Deutschland? Oh, so it is Deutsch. Okay,
Yeah.
I said okay. The introduction to simple quantum algorithm. Oh, there's an issue there. My quantum lab is you cannot see that. Oh, wait. I put it on my GitHub, so I can link the GitHub link back to you. So yes, it sounds. I have a typo there. That's fine. I have a typo there. Okay, Deutsch seems to be correct. The algorithm certainly missed the N. That's fine. So no, that's how do I add the hyperlink? Oh, it's automatic. Okay, there.
Yeah.
So so you can download it and upload it into your IBM Quantum Lab environment. Hopefully it works.
Just make sure that you publish that, Professor. Yes.
Yeah. Okay. Week 8. Okay. Yeah. So put it there. Yeah. All right. So let me know if you have trouble to run that. Yeah. The link seems to be working though, at least, even though there's a typo. So, yeah. Okay. Study that, and I'll see you next week. Okay.
Okay.
All right.
Thank you.
Sure. Bye.
Bye.
Bye, everyone.
Bye.